This looks more complicated than it actually is. In economics, the marginal cost is the cost of producing one more unit. This can be approximated by the gradient of a cost curve. So, effectively, what this is telling us, and this is repeated in the question, so you don't actually need to read the first sentence by chance, but it's important to understand all the information, is that if we have a function, and let's say our function is going to look a bit like this, this has got several different gradients depending on which point you're studying. If you're studying at this point of the graph, it's going to have quite a steep gradient. Here and here, the gradient will be 0 because these are local minimums and maximums. So what it's saying is that the original function I drew, the cubed function, is going to be the cost curve, and its gradient is the marginal cost. So it then continues, and you might want to pause the video, to say, write down the daily cost to the company if no helmets are produced. So it says above that the daily cost function is C of x, where one variable x will represent something and then C of x will represent something else. It says x is the number of helmets. So it's saying to us when no helmets are produced, all you need to do is take this function and replace the variable which represents helmets, which happens to be x, with 0. If you're quite good with maths, you can see straight away what the answer is, but most of you will not be able to see this straight away. So I'm going to show you how to do this with a y equals. We're going to clear both of the functions. On the y equals, what we're going to type is the function 600 plus 7x. Note I didn't press the 7 clear enough. Minus the large minus as it's in the middle of the equation, 0.0001 x to the power of 3. Now this will tell us the cost depending on the different amounts of helmets. So if we press the second table, you can see that the window set is a bit strange. It's going up in different amounts. We can't have 5.8 helmets, so we want it to go up in ones. So press the second window, this is table set, and change the table button, which is the second button down, so it's going up in ones, not 0.2s. Press the second table, second graph, and see why this hasn't changed. We want this to start at 1. Or perhaps we want to start this at 0 because we're talking about 0 helmets. Second graph, there we go. So when we produce 0 helmets, the cost is 600 and it goes up as so. Of course, it's going to get more expensive. So write down the daily cost to the company if no helmets are produced. The answer is simply going to be looking in the table for when x is 0, and we could see that when x is 0, the answer is going to be 600. So our answer is going to be 600. Now please note you could have done this without the calculator. If you take this particular function, you substitute in 0, 7 times 0, or any number times 0, make sure it disappears. This disappears, this disappears, and we're just left with a 600. So you could have done that in your head. Find the expression for the marginal cost. Now all it wants you to do is differentiate. Differentiating the number goes to 0, 7x goes to 7, minus 0.0001x cubed goes to minus 0.0003x squared. We times the variable or the number in front of the x cubed by 3, its power, and then reduce the power by 1. This is our answer as discussed. Then it says find the marginal cost. So as talked about before, marginal is to do with a gradient. Differentiating, which is this, is to do with the gradient. The marginal cost of 20 helmets and 80 helmets is to do with substituting into the differential equation. So again, you can do it algebraically or with the calculator. I'm going to do it with the calculator and algebraically. I'm going to go back to the y equals. I'm going to leave this here because this shows us the differential curve. Now, for some reason, we cannot see very much. And the reason why is because this is quite a large variable. So we're saying that at the cost of 0, y or c of x should be 600. So I'm going to change the window. And first of all, I'm going to quit from here. I'm going to go back to the window. We want the max to be very large. This represents the cost. Let's change this to 1,000. We cannot have a negative cost in this instance, so let's change it to 0. Let's go back to the graph. Now that's looking better, but there's still a lot we cannot see. So let's change the x so it's bigger. Let's change this so it's between minus 100 and 100. A common mistake I see here is putting 100 in x min and minus 100 in x max. Remember, this is the smallest, this is the largest. Click graph. Again, we cannot see too much. Watch what I'm doing here. Of course, this is getting much better. What we cannot see is now the absolute maximum or the local maximum and the local minimum. So we need to make the y's bigger and smaller. So we're going to go on to the window. And for our y minimum, we're going to make it a bit smaller. Y maximum, let's change it to something a little bit bigger. Let's change it to 2,000. See how this alters the graph. Much better. Still can't see it all, but that's fine. Now, it's talking about substituting into c dash of x formula. Now, if you got this wrong in the exam, this is fine. You get method marks, so please write something down for part B, even if you don't understand how to do it. Go on to the y equals button, and we are going to write on the y equals button the new function we have. 7 minus, we pick the large minus, 0.0003. Then we're going to go for an x squared. Then we're going to press graph. And this is going to be representative of the gradient of this function. So using the second equation, we want to find the marginal cost of 20 and 80 helmets. So let's go to our table. We need to look at the second graph. 20 helmets is going to be represented when x is 20. So we say when we have 20 helmets, this is going to be our cost, 688. There we go. And then when we have 80 helmets, just keep scrolling down, look for when it says 80, our cost is, as expected, 508. Another easier way of doing this would be just to substitute exactly in this formula. So you just take this formula and then rather than writing x squared, you're going to write 20 squared. So you would do the following. 7 minus 0.0003 times x squared. So x is going to be 20 squared, so 20 times 20. I would also make sure you put brackets, so you're ensuring that the calculator is applying BODMAS. There we go, there's our answer. 7 minus 0.0003 times 20 times 20. That's all you need to do rather than applying it on the calculator. Part D, state appropriate units for the marginal cost. So this is to do with helmets. It's the cost of helmets. So you say cost What is the units, the cost in dollars? Because it says US dollars, you can do the symbol or write the word per helmet. Last but not least, it says a hammock can be modelled by the function f of x equals 2x squared plus 3x minus 4. A mosquito travelling in a straight line of gradient 11 touches the hammock at point A. Find the coordinates of A. Now you need to think about this question carefully. We're going to have a function. Our function is going to be a quadratic function. It's going to look something like this. For example, it's a happy face or an upward facing parabola because the number in front of x squared is positive, and it goes through -4, so it goes through in the negative quadrant. The negative quadrant's here because of the -4c value. The mosquito travels in a gradient of 11. So if they're travelling in 11 or a gradient of 11, they're going to be travelling in this kind of direction. Now, the problem with this, we don't know where the mosquito's travelling. It could be travelling here, 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 etc. We want to find a point when the mosquito touches the hammock. Now, the hammock and the mosquito can intersect. Here they're intersecting. They're actually crossing each other. But touching means they don't actually intersect. They just touch and then they move away from each other. So we want to find around about this position. So what we need to do is we need to find the gradient of the original curve, which is the hammock. Obviously, we find the gradient by differentiating and then just set it equal to 11. That's all you need to do. So you take this equation, 2x squared plus 3x minus 4. What we're going to do is we're going to differentiate it. So if we differentiate it, we get 4x plus 3. We bring the power down, the 2, times it by the 2, 4, reduce the power by 1. The 3x, or a number x, just changes into the number, and we're just going to set it equal to 11. All we need to do is solve this simple equation, and x equals 2. Again, if you're not happy solving basic equations, which I'm sure you are, you can go onto the calculator, click y equals, click clear, go up here, press 4x plus 3, and then we want to see when this equals 11. We press second table, we scroll up. This is a lot of work when you could just do some basic maths for me. And eventually you're going to see that when y equals 11, which is here, x equals 2. Nice and easy. I hope you found that worded differentiation problem helpful. Now what I'd recommend you do is have a go at some of the following questions. I'm going to put them on the screen now. Please pause the video and have a go at these.